Hi everyone, welcome to my video. Today we're talking about quadratics in vertex form. I have some other videos about quadratics that are in standard form, that ax squared plus bx plus c. But now we're going to talk about quadratics when they're in a special vertex form, which I think you're going to really love because it really helps us see the transformations from the parent function to our new function. And then we're able to see how the new equation is actually built, what those values mean for a, h, and k, just like they did for absolute value functions, a, h, and k. They're going to do the same thing here for quadratics. So let's take a good look together. All right, so first thing that we need to make sure we know from our a values is that we have some special rules. In this function, we should see that we have a, h, and k, just like we did in our absolute value functions that I just mentioned. They basically mean the exact same thing they meant before. If you have an a value that's greater than 1, or the absolute value of a is greater than 1, so it could be 3, it could be -3, okay, that's going to make the graph of our parabola get very narrow. So if my parabola starts like this at an a value of 1, if the a value is 2, it's going to get skinny. If the a value is 3, it's going to get even skinnier, 4, 5, and 6, and so on. If my a value is some value between 0 and 1, so if it's a half or if it's a -half, because notice I have the absolute value of that an a value of a half or any number between 0 and 1 is going to make the graph actually wider. All right, so an a value of 2 will make it skinnier, but an a value of 1/2 will actually make the graph wider, and we're going to take a look at those examples. And now if the a is negative, it's going to make that graph reflect vertically. So the graph is actually going to be facing downwards like this. All right, so if it's a +2, the graph will look like this. If it's a -2, it's going to be flipped upside down and look like that. H is about your horizontal shift. Now notice that the formula is x minus the h value. So if my h value here is 3, it's going to say x minus 3. And if my h value is 3, that means it's going to move 3 units to the right, because when you have a positive h value, it's going to move to the right. If your h value is negative, what's going to be the special situation that happens here, if let's say the h value is a -3, well, x minus a -3 is going to turn this into a +3 here in our equation. And we're going to, again, see that very soon. My k value is my vertical shift. So if it says +1 at the end, it means the graph shifts up 1. If it says -2 at the end, it means the graph just shifts down 2 units. All right, so we're going to take a look at graphing this function that's in vertex form, and we're going to base it directly off of what the parent function would have been on this graph. So I'm going to go ahead and I'm going to graph the parent function first so that we can remember what that would look like. So my vertex is at 0, 0, then 1, 1, 2, 4, -1, +1, -2, +4. If I was to go ahead, like I mentioned, and just graph my parent function, this is it, okay? It's simply f of x equals x squared. But now I want to graph this new function that we're given. So what I need to see is I need to figure out the vertex. Now, the form for the equation is f of x equals a times x minus h squared plus k. So here, let's take a look. If my h is my x value for my vertex, and I see x minus 1, but my form is x minus h. Well, let's see, my x minus is there, so my h is actually that 1. Okay, if the form is x minus the h value, I see x minus 1, that means my h is 1. My k is whatever this number is at the end of my equation. And if I see -3, then it's really -3. Now, usually what my students will say to me is, oh, so Mrs. Yakubov, is it just the opposite sign here? And I can say yes to that. That is what ends up being, but I don't want that to be the way I teach it to you. It's always x minus the h value. So if you see x minus 1, then the h is 1. If I saw x plus 1 here, that would mean that the h value is actually negative, because x minus a negative would turn it into a positive. We'll again see that in a little bit. So what I'm going to do is I'm going to take this new vertex of this function of 1, -3, so +1, -3, and I'm going to plot it. Now, if that's the vertex, I want you to notice Look at the original parent function vertex. How does the parent function vertex go to this new vertex? It goes 1 to the right. So that's what this is saying, go 1 to the right. And then it's going 3 units down. The vertex is actually telling me what the transformation is. Well, part of it. So if I was to take this vertex and just move it 1 unit to the right, 3 units down, what if I did that to all my other points? What if I took this point here and I went 1 unit to the right, 3 units down? This one. 1 unit to the right, 3 units down. 1 unit to the right, 3 units down. 1 unit to the right, 3 units down, which is actually this point here. And if I graph that, that would be my function. Now, the reason why that went so smoothly too is my a value here, guys, was 1. And when you have an a value of 1, the shape doesn't change. So it's not going to, like, it's going to get skinnier if my a value was 2. It's not going to get wider if my a value was, let's say, a half. And it's not reflected vertically like this because my a value is not negative. So I would say my transformation from the parent function to go from the red graph to the blue graph is that I went right 1 unit and then down 3 units. And my vertex actually tells me that transformation. So the moment I look at an equation and I see the vertex tells me exactly what I'm going to do next. So we're going to take a look at 6 different graphs that all deal with this same exact idea. Follow along with me. Feel free to copy things down, pause, jot something down on a whiteboard, piece of paper, whatever it is, to see if you can figure it out. Now, I've already graphed the parent function for us. So really what we're going to do is we're going to look at this function, we're going to figure out our vertex, we're going to plot the vertex, and then we're going to make our graph. So here it says x minus 2. So we learned the formula is x minus h. So if the formula is x minus h, then my h value here is that positive 2. My k value is this number at the end of my equation. I don't worry about changing any signs, no tricks with that, guys. So my vertex is 2, negative 4. Let's go ahead and plot that new point of 2, negative 4, which would really mean that if I'm taking my original vertex at 0, 0, and my new vertex is at 2, negative 4, then I'm moving every single point to negative 4. But let's remember one thing as well. When your a value is 1, what that really means is that I go out 1, up 1. Remember that plus 1, plus 3, plus 5 rule? Well, it works here for graphing really nicely too. So I go out 1, up 1. That's my plus 1. Then I would go out 1 unit, up 3 units. That's my plus 3, just like we did in our tables. And if I do that, take a look. That is my new parabola. The transformation from the parent function is that I went right 2 units and then down 4 units. If I was to really look at every single point from my original parent function graph, that's what that new graph would be. And because my a value is 1, I didn't need to change any kind of values at all. Okay, let's look at this one. Now, this one does have a negative a value, so that's immediately going to tell you that this graph will get flipped upside down. I see x plus 3. Now remember, the formula was x minus 3. I'm going to write that in here. So if the formula is x minus h, but I see a plus 3, then that would have to mean that my h value is really a negative 3. Because think about that. X minus the negative 3 is going to turn it into x plus 3. So my h value, my vertex, is a negative 3. My k value is the number at the end, and I don't see anything, which means that my k value is 0. Now, not only does this tell me where my new vertex is, I'm going to go ahead and plot that, negative 3, 0. But my a value, guys, my a value here is a negative 1. And we learned that a negative a value means that it's going to be a reflection vertically. So not only does this graph get shifted 3 units to the left, but it also gets flipped. So instead of going to the right 1 and up 1, I would go to the right 1 and down 1, to the left and down 1. Okay, and then instead of going up 3, it would be to the left and then down 3, to the right and then down 3. And this would be my new graph. So this function got shifted to the left 3 units, 1, 2, 3, and then it flipped. Okay, next two. I'm going to put myself in the middle here. So vertex, if the form is x minus h, and I see x minus 2, that means my h is 2. My k value, I don't see anything at the end, so that means it's 0. Now, the a value of 2 is going to mean that it's going to be a skinnier graph. And instead of going out 1, up 1, out 1, up 3, it's going to double. So remember, if the a value is 2, that means it goes out 1, up 2, out 1, up 6. It doubles. So instead of plus 1 plus 3, it's plus 2 plus 6. So if I go ahead and I plot my vertex at 2, 0, because it's shifting 2 units to the right, so that's what that h value is going to tell me. But instead of going out 1, up 1, I'm going to go out 1, up 2. Out 1, up 2. Now, I'd love to be able to go out 1, up 6. It would be somewhere up here. I can't fit that on my graph, but I can definitely see that this graph is definitely skinnier, more narrow. So the transformation here is that it went to the right 2 units, and it's a more narrow graph. Let's look at the next one. Negative 2, so that means it's going to be a skinny graph, plus it's going to be reflected upside down. X minus 1 squared plus 1. So if it's x minus h, and I see x minus 1, that means my h value is 1. If I see this plus 1 at the end, that's also a positive 1. So I'm going to go ahead and I'm going to plot my vertex at 1, 1. It is negative, so it's going to reflect. And if it's a negative 2, the positive 2 here meant plus 2 plus 6. If it's a negative 2, that a value is going to tell me to do negative 2, negative 6. So I'm going to go out 1 unit, down 2 units. Out 1 unit, and I would go down 6, but I can't fit that. But I do know that it's going to be this very skinny graph. And it's reversed. So, reflected rather. So it goes this from the parent graph, it would go right 1 unit, up 1 unit. That's my vertex, 1, 1, and then reflected vertically. Last two problems here. So my vertex, I just see x. I don't see x minus something or x plus something. So that means my h value for my vertex is 0. A negative 4 at the end would tell me negative 4. So I'm going to go ahead and I'm going to plot that point at 0, negative 4, which already tells me my parent function is just shifting down 4 units. Okay, now the 1/2. So 1/2 would tell me instead of going up 1 to the right 1, up 1 to the left, up 3 rather, it's going to get multiplied by 1/2. So I would go up, out 1, up 1/2. Because instead of plus 1 plus 3, it's going to be plus 1/2 plus 1/2. Okay, I'm literally just cutting those numbers in half. So then out 1, up 1/2. That's going to be here. And I'm just going to make my mirror images. Now, usually when I teach this part, students may be like, well, I'm kind of having difficulties with it, like, can I just make a table? And that's always true. And that really could be the case for any of this. So imagine for a moment you really just wanted to plug points in. Here's the x value at 2, right? That has an x value of 2. If I plugged in 2, 2 squared is 4. Half of 4 is 2. 2 minus 4 is negative 2. So look, that's where this point is. If I was to plug in a positive 1, and I wanted to know where that point would be. 1 squared is 1. 1 times 1/2 is half. 1/2 minus 4 would be negative 3.5, which is where that point is. Now we should see that when we make this graph, whether we use the a values to help us or we make a table, this graph is a little wider. It's not super, super wider, but it is definitely wider. So this graph went down 4 units, and there's also a wider graph. Last one. X plus 1 would mean that my h value of my vertex is a negative 1. Plus 2 at the end is my plus 2. I see it's negative, so that's going to mean my graph is going to reflect vertically. So I'm going to go ahead and plot my vertex of negative 1, 2. So I already know that my graph is going to shift 1 unit to the left and then 2 units up. but I have to reflect it vertically from this point. So from this vertex, if my A value is a -1, which it is, that means I'm going to go down 1, down 3. So out, down 1, out, down 3. Same thing on the other side. Out, down 1, out, down 3. And so this graph went to the left 1 unit, shifted to the left, went up 2 units, and then reflected vertically. I hope this video was helpful for you. I know it's a lot of information. Please rewatch if you need to, and thanks for watching.